Here comes an application problem for the distance formula. We are asked to find the distance between 2 points. The first one has the ordered pair xy equals pi over 2, comma, 0. Now, yeah, pi has an approximate value of 3.12, but that's a rounded value, so it's better just to write it as pi. That's an exact, precise value. We don't have to write all the decimals, which, by the way, we can't do because they're infinitely long. So it's better just to write it as pi over 2, comma, and the y value is 0. And the second ordered pair, xy, is pi over 3, comma, 1. Now, to find the distance between these 2 points, we're going to apply the distance formula. D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So the difference between the x squared plus the difference between the y squared, and then take the big square root. Now, x sub 1, y sub 1 is the first ordered pair, and x sub 2, y sub 2 is the second. So D is equal to the square root of, parenthesis, pi over 3 minus pi over 2. Those are the values, x sub 2 minus x sub 1, parenthesis squared, plus 0 minus 1, parenthesis squared. Simplify, we get a common denominator, 2 pi over 6 minus 3 pi over 6 squared. See, we have a common denominator of 6, so we rewrote each of those fractions with a denominator 6, so we can subtract them. And then add negative 1, parenthesis squared. Now, the first parenthesis gives us negative pi over 6 in parentheses squared plus negative 1 squared. Now, let's do the squaring. We get the square root of pi squared over 36 plus 1. And that, getting a common denominator with 1, we have pi squared over 36 plus 36 over 36. So under the radical sign, we have pi squared plus 36 all over the common denominator, 36. Okay, we can bust that up, top and bottom, and then simplify the bottom. The top is the square root of x squared plus 36. The bottom is just 6. Now, there's no way to simplify the numerator because we'd have to have a perfect square factor, and we have the sum of 2 perfect square factors. If we could factor that and get a perfect square, a single perfect square, we could get rid of the square root symbol, but we can't. The factorization involves imaginary numbers. No sense in going there. That's as good as it gets right there.